Okay, number 7 says find the volume of the solid generated by revolving the region bounded by the graphs around y is equal to 6. So this is different. This is not just an axis of y is equal to 0 or x is equal to 0. So, step 1. What do you think step 1 is?
Draw the bounded.
There you go. Draw the area bounded. So here we have y is equal to x. Here we have y is equal to 3. And if I were to write this as an intersection, can you quickly tell me what that intersection is? 3, 3. Okay, we might need it. Why not? Now, x is equal to 0. And already the area region bounded, I can definitively say, will be between these 3 lines. Okay? Now, step 1 is done. We're now going to revolve this. Where is it at? Revolving around y is equal to 6. And this may help you. If I ask you to draw y is equal to 6, you know it's going to be a horizontal. And if I'm rotating it around this horizontal piece, right now you should know whether it's dy or dx. It's dx, because these are vertical slices. From your perspective, they're vertical slices. You with me? They're not doing horizontal rotations like this. They're doing vertical rotations about a horizontal line. That's big. Okay? So, we have dx. We're about to set up our integral. Done 2 steps so far. What would you think my next one would be from here? We could find the bounds, but even before then, I think what's more important is to determine what?
The equation.
The equation. Is it a washer method or is it a disk method? It's a washer method. So this memorized washer method with the pi GCF'd out is going to be big pi r squared minus little pi r squared. And again, the pi is GCF'd out. Okay? Yes?
Are you always going to have to use pi, or can you use like area of like another shape?
So this is a good question. Could you use areas of squares, rectangles, and so on and so forth? You could. But those don't revolve around an axis. Those are perpetrated throughout the, you know what I mean? Another word is matriculated throughout the interval. They're just a bunch of slices put together. Nothing is revolving. Okay, so that's a really good question. So when you are revolving, it will always be the shape of what? A circle. Not an ellipse, a perfect circle, okay? So here we go. We are going to see that this is going to be a washer method. And again, just for instructional purposes, we're going to go over here to our little drawing, and we're going to create our circle. And this is called an arbitrary circle because they're going to be different throughout this entire interval. Okay? And this circle, from side view, I'm going to try to make this even better than the last one, is going to look something like this. And you want to pick a circle in the middle of the interval. Okay? So let's say this comes out of the paper. Oops, let me use black. Comes out of the paper and then goes back into behind the graph. Oh, before I do this, there's something that I haven't yet drawn. Y is equal to 6. So otherwise, this is way wrong. Alright, so I was in automatic pilot mode and I was trying to do revolving around the x-axis. Let's do, since this is very important, we're going to do is y equals 6 way up here. So we'll say right here. Here is y is equal to 6. And what I want you to envision is you're going to pull this area out of the page and go all the way around like a big circle around this axis of revolution. Okay? So here we go. When I pull this out, let's say we're going to have a big R, and we're going to do big R, let's keep it in red. And big R is going to go from the center of rotation to the outermost function. From the center of rotation, notice how I always start there and go to the outermost function of the area. You with me? Now, since I'm doing it right now, I'm going to keep, let's say, in orange. This is little r. So, from the axis of revolution to the innermost function of the area, that's where I'm going to stop. That would be from the center to the innermost function, right there. So I have big R and I have little r right now. Let me draw it popping out of the screen now. So popping out of the screen, it's going to look something like the following. This will come out and then go behind the paper. And then the other one will come out and then go behind the paper. And all of these have a cross section similar to the color that we have to the right over here, as far as showing these arbitrary discs that exist as it slides through the integral from A to B. Okay? Now here we go. I've drawn the circle on purpose to see if you don't mess up the second part, the next one, the next step coming up. This is big R. Can someone tell me on big R, what's the top function? 6. The top function is the top value of that big radius. And the way I drew it, the top value of that big radius is 6. Now, we're still looking at this red line. Okay, this red line. And just so that you can see it, those of you especially in the back, I'm going to highlight this in green. That's what we're looking at right now. Okay, what's the bottom function of that? X. So it'll be 6 minus bottom. That is big R. So I square it. Okay, let's move on to the other one. And I'm going to highlight this one in green right now. We're now looking at the little r. You with me? What's the top function? 6. What's the bottom function? 3. And this is going to be bounded from what to what? From 0 to 3, because I'm looking at vertically from the x-axis, or sorry, y-axis, to x is equal to 3. Why do you think I did not draw any radii that were going from the center up? Why didn't I draw radii that were going upward?
Because pi doesn't, when you multiply by pi, doesn't get all the...
It's still going to get it all anyway. And up here, I didn't have functions up here. There were no y is equal to 20 or stuff like that. There was nothing up here that showed that those would be my top functions. Any questions before I close this? So integrating that, putting it all together will give you 36 pi. Cool? That's the volume. So you, on the test, I don't just want you writing 36 pi. What do you think I want you writing? Units cubed, or feet cubed, or whatever it is. Okay.
Does the second part even matter to integral?
Does this part here matter to integral?
Yes.
Is it 0?
No.
So it does matter.
But it's being subtracted from both parts, so if it's the top minus the bottom, it won't matter.
I don't understand what you mean by that.
Well, so let's say it's 50, right? It's not going to change the answer. That's what I'm saying. So long as it's a constant.
So let's, if we were to write this out, it would look like this. Minus what? 9?
Yeah.
You all agree? 6 minus 3 is 3, and then squared is 9. He's saying, does it matter to have the 9 there?
Yeah.
It does, because when you integrate it, it's going to become 9x, right?
So we shouldn't subtract 36
Okay, so let's FOIL this out real quick. So we have 36 minus 12x squared plus x squared minus 9. It's not just 36 minus x squared. Remember that, okay? So FOILing that out, this is what I really have. So it's like, you could say a negative 11x squared, then what? Oh, my bad, my bad. Nice catch, nice catch. So it's going to be an x here, right? So it'll be a negative 12x plus x squared. So if I did write this out, let's go ahead and do it. We have x squared minus 12x plus what? So minus 12x plus what? 27. And it's dx from 0 to 3. Yeah, it's good practice to do it. I mean, some of us forgot to FOIL that other one. I messed up the FOILing anyway. So the integral becomes what? X cubed over 3 minus 6x squared plus 27x. It's from 0 to 3. And then at the very end, one time, I'm going to work with this. You see what I'm doing? Just regular integral from here. If I plug in the 0, that zero's out, right? But if I plug in the 3, let's plug in the 3 here, here, and here. We get 27 divided by 3 is 9. We get minus 54. Do you agree? And then plus what? Plus 81. So you have 81 minus 54, 7, 2. So you get 36. Because you add 9 to it. So you get 36 pi.
So going back to finding the 6 minus x and 6 minus 3, so is it like, so you take the farthest point on the bounded region from the,
I'm having trouble following your question.
like how do you figure out what r is square?
So
6 minus,
this right here,
yes.
just FOIL it. Like what's 6 minus x squared? 30.
No, he's asking like, how did you find your big R and your little r in this equation?
Yeah.
Oh, how did I find the big R? What's squared?
Yeah.
So that's big R squared, right?
Yeah.
And then little r squared. So the default for memorization were those pieces. You agree? So what we did is, to find these r values, what was in red here, the big radius, we did top minus bottom with that big radius. What was over here in orange, right here, I'm going to do it green, that small radius, we did what was the top minus bottom to get that small radius. And then just plugged them in, solved it out like a normal integral from that step.
So the bigger radius minus the smaller radius.
Because remember, the bigger radius minus the smaller radius creates something that looks like that, a washer. Hence the washer method.